Imagine as an AI developer, you're trying to run your Python code, only to realize that your most used packages are not working, let alone some of them are not even ported. And this is the reality we face. Python is an essential development tool for AI developers. However, lack of support for RISC-V architecture is presenting a major challenge. Not having binary packages ported for essential libraries like NumPy, the developers are left to struggling to compile the most complex libraries by themselves. So what can we do as a community? Let me go back. Okay, so I have been lucky enough to be in the thick of ecosystem development for hardware, software, and silicon partnerships. And in these experiences, working in Android, Chrome OS, Oculus, now RISC-V, I have seen firsthand that collaboration and alignment is key to success. And we've been talking about collaboration all morning at the Google Keynote, Google breakfast this morning, and the panelists earlier as well. Collaboration is key to success. So mobilizing software ecosystem and building a strong and robust RISC-V software ecosystem requires that collaboration and that alignment. And we need to bring together your expertise, your passion to the RISC-V software ecosystem. And let's dive into how we can mobilize the RISC-V software. We are seeing, and we're talking about all morning, how rapidly RISC-V software ecosystem or RISC-V architecture is evolving. And the Omdia Server Silicon Market Analysis recently highlighted that while RISC-V ecosystem is advancing and maturing, we are seeing rapid advancement compared to the ARM architecture. And now, how do we build based on this momentum? We build this momentum by focusing on 3 key approaches. First, collaboration and community engagement. It's all about getting the community together and work with open source developers. Second approach, investing in the software stacks. Fundamentals of the software stacks are key, so everything it builds on top of that will benefit. Third, continuous commitment to software porting and optimization. So let's dive into each of these pillars. Collaboration, coordination, and community engagement is key to empowering RISC-V software ecosystem. When we encourage developers to actively participate, developers, OS communities, we can build together strong software. Let me highlight a recent exciting example of our collaboration. Thanks to RISE and Adopt Team's collaboration, now Java has made its way to RISC-V architecture. Yay, let's celebrate. That's a good win. What does this mean? This means Java developers can fully leverage RISC-V architecture in all important versions of Java, Java 17, 21, 23, 24. So we unlocked a whole slew of developers to work on RISC-V architecture. That is a good highlight of a collaboration. So maturation of the RISC-V software requires coordination efforts and aggregated investment. I'm going to repeat that. This is very important. Aggregated investment. Let's raise our hands if you or someone in your team worked on a problem only to realize someone else is working on the exact same problem when your patches were upstreamed. I see a few hands up, Red Bear there, a few of you guys. Yes, we've seen this more than a few times. When our patches are upstreamed, we're realizing someone else is working on it. So we need to be able to coordinate and direct our resources efficiently because there's enough problems to solve. We don't have to work on the exact same problems. So continuous aggregated investment is essential. And these investments are not the only piece to the puzzle. At the end of the day, results matter. And how do we get those results? We get those results by our shared commitment, our collaboration, and effectively communicate our wins. So this is our first pillar. Let's look into our second approach, investing in the software stack fundamentals. In the morning, we talked about the missing pieces of the software stacks. So let's take a look at, luckily, RISC-V is strong at IoT, embedded, automotive, and these areas share the commonalities in the software stacks for client or server environments. So we need to take advantage of these commonalities and build that software stacks. Let's take a look at what are these three key areas of commonalities. Core operating system. Linux is everywhere, whether it's your IoT applications or server environments. Linux is common and everywhere. Second, shared libraries and frameworks. Libraries like OpenSSL for crypto, OpenBLAST for linear algebra, or SLEEF for computations. These are common libraries, integral across the board. If we get these libraries solid, we solve a lot of problems as well. And third, toolchain. Compilers, GCC, LLVM, I see all of you working on these problems. These are fundamentals, and anything gets built on top of that benefits when we ensure our compilers are solid. If we focus on these fundamentals, we encourage deeper collaboration and create solid foundation. All right, now let's look at our third pillar, our continuous improvement of software porting and optimization. Optimization is not a let me do it once and I'm done and let me move on thing. It needs to happen over and over again. First, before we optimize, we need to know what we need to optimize. We need to understand where and how we can optimize. This is where RISC-V optimization guide that was published by RISE earlier in the year comes into a picture and can provide a very valuable resource. It's available on GitHub. Take a look at it and use it, contribute back to it. We would love a more participation there. It's offering a great best-known methods for toolchain developers, OS engineers, especially those of you working on performance-critical libraries. It's a great resource, and we'd love to see more activity there as well. And remember, optimization is not a one-time deal. And just yesterday in the expo hall, a developer shared with me a great story, and I love hearing these. There was, in Java ecosystem, they realized using a register link was really holding the performance back significantly. Just by swapping the register link, there was a huge performance boost. And this is a great example of software just works versus software at its best. And there's many areas we can do this and gain that performance, and it all adds up. So now we're optimizing. The next thing is, so when we have new instructions, we need to port the instructions, it works well, and we optimize. This cycle needs to keep going. When we have new instructions, this whole fresh cycle starts. Krista earlier talked about RVA 2023 and its ratification. And this provides a great opportunity for us to go back and look at the instructions we have already implemented and re-optimize that. And instructions like compare and swap, bfloat 16 or fp16, we need to go back in all of those existing implementations and re-optimize those. So this cycle needs to keep going. Right. Let's go back to that Python problem that we talked about earlier. And this is going to help us to unlock the RISC-V architecture for AI developers. We are actively engaging with the Python community. We are actually needing help in building, testing, deploying, and maintaining Python binary packages for RISC-V architecture. And if you're interested, this is a great opportunity to jump in. And we're coordinating our efforts with developers to align Python packaging. So to drive success in RISC-V software ecosystem, whether that's IoT, embedded systems, automotive applications, or server environments, we need to collaborate. I'm a music person, so it's like creating an orchestra. Every note, every participant is adding a unique node to the ecosystem. And we talked about the 3 pillars, and I'm going to repeat that. We need to invest in our developers and invest in our collaboration. And we want to celebrate every small win, whether that's very small or big. Java was one of them. Rust is getting ported. Each of these wins, we want to communicate, we want to celebrate. And focus on the fundamentals of the software stacks. Like we said, everything gets built, applications gets built on top of these software fundamentals will benefit if we optimize throughout our software stacks from firmware all the way to applications. And the last one, commitment to continue improvement. As we say, as the saying goes, Rome was not built in a day. We need to keep going, and this is a long road. Iterative approach of software porting and optimization is key. So let's take an action now. Please join us building a stronger software ecosystem. I encourage you to get involved, whether that's Python packaging problem that we talked about, or contribute back to the optimization guides, or any other initiatives that's going to tip the scale to the right direction. And I'll be around after this. I'd love to brainstorm other areas we should look at, and how do we motivate developers or maintainers and appreciate their work, not just motivate them, because they're passionate and they're already doing a great work in this space. So I look at it as these are the good old days. We're going to look back in this moment and say, I helped to build RISC-V architecture. I helped to advance RISC-V software ecosystem so that every technology that's in our lives have been touched. Please join me in building the future together. Thank you.